Deep beneath the surface of the earth, in a place where sunlight has never reached, there is water. It rests in the dark. It has rested there for a very long time. In a mine in Canada, far below the footsteps of the living, geologists have found pools of water that have been still and quiet and waiting for more than 2 billion years. 2 billion years. Before there were forests, before there were fish, before anything with eyes existed to see the light that this water has never known. And yet it remains, patient, unchanged, held in the arms of ancient rock, in chambers carved by pressures we cannot imagine, in a darkness so complete it has no memory of stars. The water does not flow, it does not seek the sea. It simply is, as it has always been, as it will continue to be, long after we have forgotten to wonder about it. Consider for a moment the soil. Not a field of it, not an acre, just a single teaspoon lifted from the ground on a spring morning when the earth is soft and dark and smells of rain. In that teaspoon, smaller than your thumb, there are more living things than there are people on earth. Billions of them, microorganisms so small that 1,000 could rest on the point of a pin, bacteria that have been breaking down leaves and roots since before anything walked upright, fungi threading through the darkness in networks finer than spider silk. They do not know we are here. They do not need to. They have their own concerns, their own slow processes, their own patient work of turning the dead into food for the living. And this work continues beneath our gardens, beneath our roads, beneath the places where we lay our heads at night. The soil does not rest, it only appears to, underneath, always, the quiet industry of countless small lives, building the world one grain at a time. We speak of forests as the lungs of the earth. And there is truth in this. The trees do breathe. They take in what we breathe out and give back what we need. But the forests, for all their grandeur, are not the source of most of our air. That honor belongs to the sea. In the sunlit upper layers of the ocean, drifting with the currents, are countless tiny organisms called phytoplankton. They are so small you cannot see them. A drop of seawater might contain thousands, millions. And each one, in its own quiet way, is photosynthesizing, taking in sunlight, releasing oxygen, breathing out the air that will eventually find its way into your lungs. Most of the oxygen you have ever breathed began here, in the sea, in the bodies of creatures too small to name, too numerous to count, too humble to notice. And they continue, rising and falling with the tides, blooming in spring, fading in winter, breathing, always breathing, for all of us who live above the waves. The Great Barrier Reef stretches for more than 1,000 miles along the coast of Australia. It is so large that it can be seen from space, a ribbon of color in the blue, a structure so vast that it dwarfs anything humanity has ever built. And yet, it was made by creatures smaller than your fingernail. Coral polyps, tiny soft-bodied animals, each one no larger than a grain of rice, each one building a hard skeleton around itself, each one adding its small contribution to the whole. They do not plan, they do not coordinate, they simply grow, each in its own direction, each following the light, and together, over thousands of years, they create something that astronauts can see from orbit. There is no architect, no blueprint, only the patient accumulation of small lives, each one building on the work of those who came before. And the reef continues to grow, even now, slowly, silently, one polyp at a time. A raindrop, falling from a cloud, reaches a certain speed and goes no faster. It does not matter how high the cloud. It does not matter how far the drop must fall. After a few seconds, the pull of gravity and the push of air find balance, and the raindrop settles into its pace. About 20 miles per hour, no more, no less. And so it falls, not hurtling, not plummeting, simply descending at the speed that raindrops have always descended since the first rains fell on the young earth. There is something restful in this constancy, in knowing that rain does not rush, that it takes its time, that every drop you have ever felt on your face arrived at the same unhurried pace. The rain has no urgency. It falls when it is ready. It lands where it will. And in its falling, it asks nothing of us, but that we notice, if we wish to, and let it pass if we do not. A cloud drifts overhead, white against the blue. It looks weightless. It looks like nothing at all. A wisp, a thought made visible. And yet, that cloud, that single ordinary cloud, weighs more than 1,000,000 pounds. All that water, suspended in the air, all those tiny droplets, each one clinging to a speck of dust, each one held aloft by rising currents of warm air from the ground below. The cloud does not feel heavy. It does not strain. It floats, as clouds have always floated, carried by winds we cannot see, casting shadows on fields and forests and the faces of those who look up. There is a gentleness in this, in knowing that something so heavy can be so light, that the sky can hold such weight without effort, that above us, always, there is water waiting to fall, patient and unhurried, taking its time. The Sahara is the largest hot desert on Earth. For thousands of miles, the sand stretches in every direction, dunes rise and fall like frozen waves. The sun beats down on a land that seems, to all appearances, utterly dry. And yet, beneath the sand, there is water. One of the largest reserves of fresh water on the planet lies hidden beneath the Sahara, an ancient aquifer filled by rains that fell tens of thousands of years ago, when this desert was green and rivers flowed where now there is only dust. The water is still there, waiting, held in the rock, in the spaces between grains of sand, in darkness that has never seen the sun. Above, the desert seems eternal in its dryness. Below, the memory of rain persists. The earth holds what it is given. It does not forget. The earth turns. It has been turning since it formed 4.5 billion years ago, spinning through the dark, carrying us with it, giving us day and night, sunrise and sunset. But it is slowing down. Each century, the days grow longer, not by much, a fraction of a second, a delay so small that no one notices, that no clock can measure without the most delicate instruments. The moon is responsible. Its gravity tugs at our oceans, and the oceans tug back at the earth, and this gentle friction, repeated 1 billion times, slowly, slowly, slows our spin. 1 billion years ago, a day was only 18 hours long. 1 billion years from now, it will be longer still. We will not be here to see it, but the earth will continue to turn, and the moon will continue to pull, and the days will continue to stretch, unhurried, as they always have. Most of the fresh water on Earth is not flowing in rivers. It is not pooling in lakes. It is not falling as rain. It is locked in ice. Glaciers hold nearly 70% of all the fresh water on the planet. Vast sheets of frozen stillness pressing down on mountains, filling valleys, covering entire continents at the poles. This ice is patient. It moves, but so slowly that we cannot see it. A glacier might travel a few feet in a year. It might take a century to cross a meadow. And within the ice, there are bubbles, tiny pockets of air trapped when the snow first fell, thousands upon thousands of years ago. Air that no living thing has ever breathed. Air from a world before cities, before farms, before writing. The ice remembers, it holds what it is given, and it waits. There is a place in the Pacific Ocean where the seafloor falls away into darkness. The Mariana Trench, a gash in the Earth's crust so deep that Mount Everest, placed at its bottom, would still be covered by more than a mile of water. Down there, the pressure is crushing, the cold is absolute, the darkness is complete. And yet life persists, strange creatures pale and soft, drifting through waters that have never known sunlight, adapted to pressures that would destroy anything from the surface. They do not know how deep they are. They do not know there is a surface, or a sun, or a world of air above them. They simply live, as they have always lived, in the deepest silence on Earth. High above the Earth, where the air grows thin and the sky turns black, there is a region of quiet violence. Here, 60 to 200 miles above our heads, charged particles from the sun collide with the gases of our atmosphere, and in that collision, light is born. The aurora borealis, curtains of green and violet, rippling across the polar sky like fabric in a wind we cannot feel. The same region where meteors burn up, turning stone into streaks of light, the same thin shell of air that separates us from the void. And on clear nights, in the far north, people stand in the cold and watch the sky move. The lights ask nothing of them. They simply appear and dance and fade, as they have done for as long as the earth has had an atmosphere to protect it. Pick up a handful of sand from any beach. Each grain has a story. Each grain was once part of something larger. Mountains, perhaps, hundreds of miles away, broken down by wind and water over millions of years, carried by rivers to the sea, tumbled by waves until every edge was smooth. The sand beneath your feet may have traveled farther than you ever will. It has been patient. It has taken its time. And it is still traveling, still being moved by tides and currents, still becoming finer, softer, smaller. One day, perhaps millions of years from now, it will be something else entirely. Sediment, rock, mountain again. The cycle continues, slow and endless, asking nothing of us but that we notice, if we wish to. The Appalachian Mountains are soft now. Rounded hills, covered in forest, gentle enough to walk, without ropes or axes, they seem like the kindest of mountains, the most approachable. But 480 million years ago, they were as tall as the Himalayas. Jagged peaks scraping the sky, snow and ice at their summits, sheer cliffs and impossible heights. And then the rain came, and the wind, and the slow, patient work of erosion, year after year, century after century, wearing down what once seemed permanent. The mountains did not resist. They simply yielded, slowly, to the forces that shaped them. And they are yielding still, even now, even as we walk their gentle ridges, even as we forget what they once were. Beneath the floor of every forest, there is another forest. A web of fungal threads, finer than hair, spreading through the soil in all directions, connecting tree to tree, root to root. These mushroom networks can extend for miles. They carry nutrients from one tree to another. They allow mother trees to feed their seedlings. They let the forest communicate in ways we are only beginning to understand. The trees above ground appear separate, each one standing alone, reaching for its own patch of sky. But below, they are joined. Below, they are one organism, sharing what they have, supporting what is weak, remembering what has fallen. The forest knows something we have forgotten, that nothing truly stands alone. In the Mediterranean Sea, there is a meadow. Not on land, but on the seafloor, a vast expanse of seagrass, swaying gently in the current, providing shelter for fish and food for turtles. This meadow is estimated to be 100,000 years old. 100,000 years. The same organism, spreading slowly across the seabed, sending out shoots, putting down roots, while above it, civilizations rose and fell. It was old when the first humans crossed into Europe. It was old when the ice ages came and went. It is still there, still growing, still patient, in waters that have changed around it countless times. The meadow does not hurry. It simply continues, as it always has, as it will continue long after we have stopped wondering about it. Fog is nothing more than a cloud that has descended to touch the ground. The same water droplets that drift miles above our heads, suspended in the atmosphere, sometimes sink low enough for us to walk through them. And when they do, the world changes. Edges soften, distances become uncertain, sounds seem closer or farther than they should be. The familiar becomes strange. We are, in those moments, inside a cloud, breathing it, feeling it on our skin, surrounded by the same substance that forms the shapes we watch drift across the sky. The boundary between earth and sky dissolves. We are neither fully here nor fully there. We are in between, in a place of quiet uncertainty where the world holds its breath. The Earth's core is roughly the same temperature as the surface of the sun. Thousands of degrees, hot enough to melt iron, hot enough to keep the center of our planet liquid, churning, alive with slow convection currents. And yet we walk above it, unbothered. The crust beneath our feet is thin, relatively speaking, thinner in proportion than the skin of an apple. And beneath that skin, the heat continues, as it has for billions of years. We build our houses, we plant our gardens, we live our lives on a thin shell above an ocean of fire. The heat does not reach us, the crust holds, and we forget, most of the time, that we are walking on a world that is still, in some fundamental way, molten. A single mature oak tree can release up to 100,000 gallons of water into the atmosphere each year. Through its leaves, through tiny pores called stomata, the tree exhales, water drawn up from the soil, through the trunk, out into the air. This is called transpiration. The tree is breathing, in its own slow way, taking in what it needs from below, releasing what it does not need above. And the water does not disappear. It rises. It joins with other water, from other trees, from lakes and rivers and seas. It forms clouds. It falls as rain. The oak tree is part of a cycle larger than itself. It receives from the sky and gives back to the sky, and the giving and receiving never ends. The Pacific Ocean is so vast that it contains its own antipode. If you were to dig straight through the earth from one point in the Pacific, you would emerge in the Pacific again. It covers more area than all the land on Earth combined. It is deeper in places than mountains are tall. It holds more water than all other oceans together. And it is quiet, mostly. Waves move across its surface, but beneath, in the depths, there is stillness, pressure, darkness. The Pacific asks nothing of us. It simply exists, as it has existed for millions of years, holding its secrets, keeping its silences, vast beyond our ability to comprehend. Lichen is a partnership. Fungus and algae living together in a single organism, each providing what the other lacks. The fungus offers structure. The algae offers food made from sunlight. Together, they can survive almost anything. Heat, cold, drought, radiation. Scientists have exposed lichen to the vacuum of space, to the unfiltered light of the sun, to conditions that would kill almost anything else. And the lichen survived. It grows on rocks, on tree bark, on gravestones, on walls. It asks for almost nothing. It takes its time, and it endures, patient and quiet, in places where nothing else can. In the Blue Mountains of Oregon, there is a fungus. It is called the honey fungus. It spreads through the soil, sending out threads, colonizing the roots of trees, growing slowly in all directions. This single organism covers 2,385 acres. Nearly 4 square miles, larger than any whale, any redwood, any other living thing we know of. And most of it is invisible, hidden beneath the surface, spreading in darkness, connecting what appears to be separate into a single vast life. The largest living thing on Earth lives underground, unseen, patient, slow. It has been growing for thousands of years, and it is growing still. The cells in your body are replaced every 7 to 10 years. Skin cells, blood cells, the lining of your stomach, all of it renews. All of it is, in some sense, temporary. But the atoms that make up those cells are billions of years old. The carbon in your bones was forged in the heart of a dying star. The oxygen in your lungs was released by ancient algae into a young atmosphere. The iron in your blood was scattered across the universe when a supernova exploded. You are made of old things, ancient things, things that have been part of countless other forms before they became part of you. And when you are gone, those atoms will continue. They will become part of soil, of water, of air, of other lives not yet imagined. Nothing is lost. Everything continues. In caves, there is a different kind of time. Stalactites hang from the ceiling, formed by the slow dripping of mineral-rich water, depositing calcium carbonate one tiny layer at a time. They grow at a rate of roughly 1 inch every 100 years. A stalactite the length of your arm has been growing since before your great-great-grandparents were born. A stalactite reaching from ceiling to floor may have begun forming before the Roman Empire rose. The cave does not rush. The water drips as it has dripped for millennia, and the stone grows as it has grown, patient, slow, indifferent to the world above. There is no hurry underground. There is only the steady accumulation of time made visible, drop by drop, inch by inch. The sky is blue because of the way light bends. Sunlight enters our atmosphere and scatters. Blue light scatters more than red, spreading in all directions, filling the sky with its gentle color. The same thing happens when you look at a distant mountain. The air between you and the mountain scatters light, giving the peak a bluish haze. The farther the mountain, the bluer it appears. The blue of the sky and the blue of the distant ridge are the same phenomenon. Light, scattered gently through atmosphere, distance made visible. We live at the bottom of an ocean of air, and that ocean has a color, and that color touches everything we see when we look toward the horizon. Over 80% of the ocean remains unexplored and unmapped. We have sent probes to distant planets. We have photographed galaxies billions of light years away, but the depths of our own world remain largely unknown. Down there, in the darkness, there are mountains we have never climbed, valleys we have never seen, creatures we have never named. The ocean keeps its secrets. It does not offer them up easily. It waits, patient and vast, for us to come looking. And perhaps that is as it should be. Perhaps some things are meant to remain unknown. Perhaps the mystery is part of the gift. Earthworms aerate approximately 7.5 tons of soil per acre each year. They burrow through the darkness, eating organic matter, leaving behind tunnels that allow air and water to reach the roots of plants. This is slow work, quiet work, work that goes unnoticed by almost everyone. But without it, the soil would compact, roots would struggle, gardens would fail. The earthworm does not know it is essential. It does not know that civilizations depend on the fertility it helps create. It simply moves through the dark, turning the earth, doing what earthworms have done for hundreds of millions of years. Some of the most important work is the work no one sees. The oldest ice in Antarctica contains bubbles of air from 800,000 years ago. Air that was breathed by nothing we would recognize. Air from a world before humans, before agriculture, before the first stories were told. When snow falls and compacts into ice, it traps pockets of atmosphere, and that atmosphere remains, preserved, waiting to be released. Scientists drill deep into the ice, pulling up cores that contain the history of our air. They can measure what the atmosphere was like during ice ages, during warm periods, during times we know only from the stories written in ice. The bubbles are small, but they hold something vast, the breath of an ancient world, waiting in the cold, keeping its secrets until we learn to ask. Rivers do not flow in straight lines. They meander, curving back and forth across the land, carving loops that seem inefficient, unnecessary. Part of this is the Earth's rotation, the Coriolis effect, gently curving the flow, pushing water to one bank and then the other. But mostly rivers curve, because that is what water does. It follows the path of least resistance. It erodes where the current is fast and deposits where it slows. It shapes the land, and the land shapes it. A river is a conversation between water and earth, a negotiation, ongoing, never finished. The curves are not mistakes, they are agreements, reached slowly, between forces that do not speak, but somehow understand each other. The salt in the ocean comes from the land. Rain falls on rocks, it dissolves minerals, it carries them down through rivers, through streams, into the sea. This has been happening for millions of years. The ocean receives what the rivers bring, it holds it. The water evaporates, rises, falls again, as rain, but the salt remains, accumulating, growing more concentrated with each passing age. The saltiness of the sea is a record of time, a measure of how long water has been washing over stone, carrying minerals to their final resting place. The ocean is patient. It takes what it is given and keeps it, and the rivers continue to bring more, slowly, endlessly, for as long as rain continues to fall. A single lightning bolt contains enough energy to toast 100,000 slices of bread. In a fraction of a second, all that power discharges from cloud to ground, lighting up the sky, heating the air to temperatures hotter than the surface of the sun. And then it is gone. The thunder follows, slower than the light, rumbling across the landscape like a memory of what just happened. Lightning is one of the oldest forces on Earth. It was striking the ground long before there were eyes to see it. It helped create the conditions for life, breaking apart molecules, making new combinations possible. And it continues, somewhere on Earth, right now, hundreds of times every second, a reminder that our planet is still alive, still electric, still capable of sudden, beautiful violence. The Grand Canyon exposes rock layers spanning nearly 2 billion years of Earth's history. Stand at the rim and look down. Each band of color, each stripe in the stone, represents a different age, a different world. At the bottom, the oldest rocks, formed before complex life existed, formed when the Earth was young and strange. And layer by layer, rising toward the present, the story unfolds, seas that came and went, deserts that grew and vanished, forests that lived and died and became stone. The canyon is a book written in rock. It took billions of years to write and only a few million to carve into view. And it is still being written, still being carved, even now. On certain nights, in certain places, the waves glow. Bioluminescent plankton, disturbed by the motion of the water, release light, the same chemical reaction that fireflies use, the same cold glow produced by organisms too small to see. The waves wash up on shore and sparkle. The wake of a boat traces blue fire across the black water. Footsteps in the wet sand leave glowing prints that fade slowly into darkness. The plankton do not know they are beautiful. They do not know anyone is watching. The light is simply what they do, part of their chemistry, part of their nature. And we are lucky enough sometimes to see it, to stand on a beach at night and watch the ocean glow with light that asks nothing of us, that offers itself freely, that vanishes as quickly as it appears. The Atacama Desert in Chile receives less than 0.04 inches of rain per year. There are places in the Atacama where no rain has fallen in recorded history, where the soil is so dry, so sterile, that scientists use it to test equipment designed for Mars. And yet, life persists. Bacteria live in the rocks. Lichens cling to the surfaces of stones. When fog rolls in from the Pacific, plants emerge from dormancy, drinking moisture from the air itself. Life does not give up easily. It finds a way, even in the most hostile places, even where water is a memory, even where the sun beats down without relief. The Atacama is a reminder that life is stubborn, that it adapts, that it waits, patient and quiet, for conditions to improve, however briefly. Most volcanic islands begin as underwater eruptions. Deep beneath the surface, magma pushes up through the seafloor. Lava flows and hardens. More lava flows over it. Layer by layer, the mountain grows. This can take thousands of years. The ocean hides the process. Above, the water appears unchanged. But below, something is rising, slowly, patient, unstoppable. And then, one day the mountain breaks the surface. A new island appears where there was only sea. Birds arrive. Seeds arrive on the wind. Life takes hold. The island does not know it was born from fire and water. It does not know how long it took to rise. It simply exists now, solid and real, a gift from the depths to the light. The rings visible in a tree trunk mark not just years, but seasons. Wide rings for wet years, when growth came easy, narrow rings for dry years, when the tree struggled, dark lines for the slow growth of winter, light lines for the burst of spring. Cut a tree, and you can read its life. Here, a drought that lasted 3 years. There, a wet decade when the forest flourished. Here, a fire that left its scar but did not kill. The tree does not know it is keeping a record. It simply grows, responding to conditions, adding layer after layer to its trunk. And when it falls, the record remains, a diary written in wood, in a language we have learned to read, telling stories the tree never knew it was telling. Peat bogs preserve organic matter so well that butter buried in them 3,000 years ago has been found still edible. The cold, the acid, the lack of oxygen, these conditions slow decay to almost nothing. Things placed in bogs stay, largely unchanged, for millennia. Archaeologists have found ancient humans preserved in peat, their skin intact, their hair still visible, their faces recognizable as people, though they died thousands of years before writing was invented. The bog does not choose what it preserves. It simply holds what falls into it, keeping it safe from time, waiting for someone to find it. Somewhere, in bogs around the world, there are things we have not yet discovered, objects, bodies, secrets, held in the dark water, patient, eternal. The Earth's magnetic field extends tens of thousands of miles into space. Generated by the churning of liquid iron in the planet's core, it wraps around the Earth like an invisible shield, deflecting the charged particles that stream constantly from the sun. Without it, solar winds would strip away our atmosphere, the air we breathe, the water in our oceans, the protection from radiation. All of it would slowly erode into space. We cannot see the magnetic field. We cannot feel it, but it is there, surrounding us, protecting us, generated by processes deep underground that we barely understand. The Earth takes care of itself, and in doing so, takes care of us. We live within an invisible embrace that asks nothing in return. The oldest rocks on Earth, found in Canada, are 4.28 billion years old. nearly as old as the planet itself, formed when the Earth was still young, still hot, still being bombarded by debris from the formation of the solar system. These rocks have been through everything. They were here before life existed. They were here before the oceans formed. They were here before the atmosphere was breathable. And they are still here, exposed by erosion, touched by sunlight, for perhaps the first time in billions of years. To touch them is to touch deep time, to hold something that predates everything we know, to feel the weight of ages in your hand. Mangrove forests grow where the land meets the sea. Their roots reach down into salt water, into mud, into conditions that would kill most trees, and yet they thrive. The secret is in their roots. Mangroves filter out 90% of the salt at the point of entry, taking in water but leaving the salt behind. The small amount of salt that does enter is concentrated in certain leaves, which eventually fall and carry the salt away. The mangrove has solved a problem that would seem impossible. It drinks from the sea and lives to tell about it. And in doing so, it creates habitat. Fish shelter in its roots. Birds nest in its branches. The boundary between land and sea becomes a place of abundance. The weight of all the ants on Earth roughly equals the weight of all the humans. Billions of tiny bodies spread across every continent except Antarctica, carrying loads many times their own weight, building nests, tending young. We barely notice them. They are too small, too numerous, too ordinary. But together, they move more soil than earthworms. They disperse more seeds than birds. They consume more plant matter than any other group of animals. The ants do not know they are important. They do not know that their combined weight matches ours. They simply work, as ants have worked for over 100 million years. We share this planet with countless small lives, and those small lives, together, shape the world as much as we do. Coral polyps, the animals that build reefs, are mostly active at night. During the day, they retract into their hard skeletons, hiding from predators, waiting for darkness. When night falls, they extend their tentacles. Tiny arms reaching out into the black water, catching plankton, feeding in the darkness. The reef comes alive with movement, invisible to those who only visit in daylight. We think of coral reefs as colorful, sunlit places, and they are. But the building happens at night. The eating happens at night. The life of the reef is lived largely in darkness. The ocean has its own rhythms, its own schedules, independent of ours. The reef does not care when we are watching. It does what it has always done, whether we see it or not. The Amazon rainforest produces about 20% of the world's oxygen. Millions of trees breathing together, taking in carbon dioxide, releasing oxygen, feeding the atmosphere that we all share. This is why it is called the lungs of the earth. But the forest does more than breathe. It creates its own weather. The trees release so much water through their leaves that clouds form above the canopy. Rain falls. The forest waters itself. It is a system complete in itself, connected to everything. The oxygen you are breathing now may have been released by a tree you will never see, in a forest you will never visit. The forest does not know you, but it sustains you anyway. Waterfalls do not stay in one place. Over time, they move upstream. The falling water erodes the rock at the base of the falls, undercutting the ledge above. The ledge collapses. The falls move back. This process is slow, inches per year, feet per century. But given enough time, a waterfall can migrate miles from where it began. Niagara Falls has been retreating for 12,000 years since the glaciers melted and the water began to flow. It has traveled 7 miles upstream. It is still moving, still carving, still reshaping the land. Nothing on Earth is fixed. Everything changes. Even the landmarks we think of as permanent are, in their own slow way, on the move. The Sargasso Sea is the only sea without a coastline. It lies in the middle of the Atlantic Ocean, defined not by land, but by currents, a vast, slow-moving gyre that circles endlessly, holding the sea in place. Within this sea, there is sargassum, brown seaweed, floating in mats on the surface, providing habitat for fish and turtles and crabs that live nowhere else. Columbus sailed through the Sargasso Sea on his way to the New World. His sailors feared the weed would trap their ships, but it did not. The sea let them pass. The Sargasso Sea has no shores to visit, no beaches to walk. It exists only as a space defined by movement, by currents, by the slow rotation of the ocean around it. Tardigrades are among the hardiest creatures on Earth. These tiny animals, smaller than the period at the end of a sentence, can survive being frozen to near absolute zero. They can survive being boiled. They can survive radiation levels that would kill a human thousands of times over. They have even survived the vacuum of space. When conditions become hostile, tardigrades enter a state called cryptobiosis. They expel all the water from their bodies, curl into a tiny ball, and wait, for years, if necessary, for decades. And when conditions improve, they wake up, rehydrate, and continue as if nothing happened. Life finds ways to persist that we can barely imagine. The tardigrade is proof that survival is possible in places we once thought impossible. The patterns in snowflakes form based on the temperature and humidity of the air they fall through. No two snowflakes are exactly alike because no two snowflakes fall through exactly the same conditions. Each one is shaped by its own unique journey from cloud to ground. At certain temperatures, the crystals grow as thin plates. At others, they grow as long needles. At others still, they develop the intricate branching patterns we see in photographs. The snowflake does not choose its shape. It receives it from the air, from the cold, from the specific path it happens to take. And when it lands, it joins with others, each one different, all of them together, forming the white blanket that covers the ground. Banyan trees can grow so wide that a single tree can provide shade for an entire village. They begin as ordinary trees, growing upward like any other, but then they do something unusual. They send down roots from their branches. These aerial roots reach the ground and become new trunks, supporting the spreading branches, allowing the tree to grow outward without limit. A single banyan can have hundreds of trunks, all connected, all part of the same tree. It becomes a forest made of one organism. In India, markets are held beneath banyan trees. Meetings take place, children play. The tree does not know it has become a gathering place. It simply grows, spreading shade, providing shelter, asking nothing in return. The mineral olivine, abundant in Earth's mantle, sometimes reaches the surface through volcanic activity. When it does, and when it is broken down by waves, it creates something unusual: beaches of green sand. There are only a handful of these beaches in the world. Hawaii has one, the Galapagos has another. The sand sparkles in the sunlight, green against the blue of the sea, the black of the volcanic rock. It looks like something from another planet. But it is from this planet, from deep within it, material from the mantle brought to the surface, shaped by waves, offered to anyone patient enough to find it. The Earth's interior touches the surface in unexpected ways. The hidden becomes visible if we know where to look.